One of the most common eye defect is what we call myopia or nearsightedness. That's the eye defect that results in people not being able to see objects that are too far away. In this case, in the case of a nearsighted eye, the far point is closer to the eye than it should be. Now, in the case of a normal eye, the far point is infinity. The eye is capable of seeing objects very, very, very far away. Now, for nearsighted people, distant objects are not going to be seen clearly. Now, in this case, if we have like in this image here, we have a diagram of a nearsighted eye. If I have an object that's further away than the far point for that particular nearsighted eye, then the image of that object is going to be formed here ahead of the retina and not on the retina. Now, because the image is not going to be formed on the retina, the person is not going to be able to distinguish that object very well. The way to correct the vision of a nearsighted person is to add a diversion lens. What happens when you add a diversion lens? The lens is going to diverge these light rays and kind of prevent them from focusing too fast. That way, allowing them to focus on the retina and make an image on the retina. Now, for a nearsighted eye, without an additional lens, this is my far point. Now, when we add the lens, what the lens is going to do is going to take a distant object and is going to form an object of that distant object at the field of vision of the eye, at places where the eye can see. So the image of the object due to that lens is going to be somewhere here, closer to the far point of the nearsighted eye. So DO for the diversion lens is going to be this. DI for the diversion lens is going to be equal to the far point of the nearsighted eye. Of course, it's going to be negative. The eye is going to be negative because the image and the object are at the same side of the lens. Okay, and actually that makes sense if you think about it. If the image is going to be real, the image is going to be inverted. So we need the lenses to provide us with virtual images. By providing us with the virtual images, they make the images appear closer at the far point, but keep them upright, keep them with the same orientation. This is an example of what a nearsighted person sees when they're not using glasses. Okay, the ones among us who are nearsighted, they can just remove their glasses and they'll see something similar. But this is what a person who's nearsighted or with myopia sees. Okay, again. So if this is my distant object, the contact lens is going to make the image of that distant object at the far point. That's contact lenses or glasses, whatever it is. So what we want is, we want to have a virtual image of distant objects. What's distant object? A distant object is an object at infinity. We want its image at the far point, at di is equal minus d far. So the focal length of the lens, if we calculate it, is 1 over di plus 1 over do. So it's going to be minus 1 over d far plus 1 over infinity. 1 over infinity is 0, so that gives me 1 over the focal length of the lens is minus 1 over d far, or d lens is just minus d far. I mean, f lens is minus d far. In other words, the focal length of the lens that the person needs to use to correct the vision is going to be equal to minus the far point of the nearsighted eye.